Note card 69, the area between curves. So up until now, we have been talking about the integrals as the area underneath a curve, right? So if I have from a to b of f of x dx, this means that if I drew f of x as my function, I am calculating the area between a and b between f of x and the x-axis, right? Up until now, we've been going to the x-axis. Today, we're going to talk about what happens when instead of finding the area between the x-axis, we're actually finding the area between two curves. So we're finding this area. Okay, so we're going to use all of our same integral properties, but we're now going to be thinking about this second function here. We're going to have two functions, like an f of x and a g of x. So I'll have two curves. I'll have f of x and g of x, and we're going to calculate the area that is enclosed between them. So in order to do that, we're going to have to figure out a couple things. We are going to need to find where they intersect. We're going to need to find our boundaries. Woo, there we go, on our own. So my A is going to be where they intersect the first time. B is going to be where they intersect the second time. I'm also going to need to figure out which one is on top. Is g of x on top or is f of x on top? Okay. Once I figure that out, I am going to be able to calculate the area using this idea right here, that if we've got from A to B, the two places of intersection, I want the function on the top minus the function on the bottom, dx. I will build that integral and then we will solve it using our normal properties. My first example, I have y equals x cubed plus 8 and I have y equals x plus 8. So our first thing to do is to draw the graphs because that will help us to figure out approximately where they intersect and also which one is on top. So I know that x cubed plus 8 is my parent function that looks like this, and it must have been moved up 8. So up at 8 is where it's crossing through, so it's going like this. Okay. And then I know that y equals x plus 8 is also going to have an intersection here, and it's going to be a straight line. Okay, so I drew my pretty small, but we're going to be looking at this little piece right here. So I already can tell from my picture that my starting place is going to be at 0. Right? So when I'm building my integral, I know that the start is going to be at 0. Okay, and we'll prove that algebraically as well. And then thinking about which one is on top. Right? It looks like my line is going to be on top. So I'm going to want x plus 8 minus x cubed plus 8 dx, and then I'm going to need to figure out where they're intersecting up here. Okay, so algebraically, two things intersect when they equal each other. So we've got x cubed plus 8 equals x plus 8. I can then solve that over here. So I've got x cubed minus x equals 0, which is very convenient. Factor out an x, and I've got x squared minus 1 equals 0. So x must be equal to 1 and negative 1, right? Looking at our picture, I don't want the negative 1. That's not what I need. I need this positive 1 right here. And I know that because it says find the area of the region in the first quadrant. So I want this piece here, starting at 0 and going until 1. And then algebraically right here is where my 0 came in. So if you didn't see that from the picture, it's at 0, it's at 1, and I don't want negative 1 because I'm talking first quadrant. So the 1 will go here. Okay, so again, review those steps. We sketched or drew the graph, wow. We sketched the graphs. Now that I have my integral all set up with my bounds, I am going to just take the integral, take the antiderivative. Simplify this first to make your life a little bit easier, being very careful with the negative here. So I would have negative x cubed plus x, and then 8 minus 8 would be 0. Of dx. I just did this negative. I did it out of order. Okay, then antiderivative. So I would have negative x to the 4th over 4 plus x squared over 2 from 1 to 0. I'm going to plug in 1. It's going to get negative 1/4 plus 1/2 minus plug in 0, and this works out really nicely for us because both of those terms are going to become 0. So I just have this to deal with. Negative 1/4, that's the same as negative 1/4 plus 2/4, getting a common denominator. So my answer is 1/4. There you go. So that means that this area between my curves up here, this shaded region, must be 1/4 units squared. We found area, so unit squared. Example 2 asks us to find the area between these 4 different places. So I'm going to draw a graph to better orient myself here. Okay, between x equals 0, so right here, and then x equals 2. Okay, y equals 0, which is your x-axis here, and then this curve here, which is going to be, we know it's E, it's growing, so it's going to be going up like this. So we've got this block in here that we're going to find the area of. This one, I don't have to calculate my bounds because they were actually given to me at x equals 0 and x equals 2. So I'm going to set up my integral, 0 and 2. And then I want the top minus the bottom. I know that this one is going to be on the top based on the graph, or the picture I just drew, minus 0 dx. So this one's actually pretty simple for us. We've got the antiderivative of e, the x over 2. We need a sidebar here because this is pretty chocolatey. We've got u is equal to x over 2, so then du is equal to 1/2 dx. Oops. So then dx is equal to 2 du. Coming back over here, I've got the integral from 0 to 2 of e to the u times, instead of dx, I'm going to put this in, 2 du. So my antiderivative of that, oh, and I used u substitution, sorry, so my bounds will change. If I plug in 0 here, I would get 0 still, so this bound remains the same. If I plug in 2, I get 2 divided by 2, which is 1. So remember, with u substitution, we have to change the bounds. We get 2e to the u, because that antiderivative is the same, from 1 to 0. I plug in 1 and get 2e, minus I plug in 0 and I get 2 times 1. So my final answer is 2e minus 2. We've made it to number 3, and this one is a calculator problem. So I'm going to grab my calculator. We've got these 2 right here. I need to first figure out where those intersect, and I need to get a good picture of this. So I'm going to go to y equals, and then I'm going to clear those out. And in y1, I'm going to type this first equation, so 1 plus the sine of 2x. And then the next one, this calculator is in Spanish, and I'm not sure why, but it's good practice for me. E to the, oops, that's not E. I want this one here, so blue, E to the, in x divided by 2 up here. All right, so I need to get a graph of that. Here's my graph. Inching its way around that way, so that must be our sine graph, and this is our E graph right here. So it looks like it's intersecting right about here. So I'm going to change my window so I can see it a little better. It looks like I only need from like 0-ish to 3-ish would be a good enough picture. So I'm going to change that here. And then it was kind of the same with our y-axis. All right, let's see what we're looking at here. That's a better picture. All right, so it looks like it's crossing at 0, but we're gonna double check that just to make sure. So in order to calculate our intersections, on this calculator, I do second calc, and I want the intersection here, and curve 1, curve 2, and then my guess. I actually wanna guess this one over here, which I'm thinking is gonna be 0, so I'm gonna move closer to right here. And, oh, it did find us this one, I think. So it found us x is equal to 1.135. 1.13, actually 1.136. Okay. And then I do know that this is going to be, well, let's make sure. Sine of 0 would be, according to my unit circle, 0 plus 1. So that would be 1. And then e to the 0 would be 1. So yes, I know that my other one is 0. So those are my bounds. So now I'm going to set this up. So I've got from 0 to 1.136 of, I need to figure out which one is on the top. Looking at my picture, the curve is on the top, and that curve was my sine graph. So I have 1 plus the sine of 2x minus my other curve, which was x over 2 dx. So if this was like an FRQ problem, On the AP exam, you would be expected to write it out like this. You've got your bounds, you've got one minus the other, and you've got your dx, making sure that that's all set up correctly there. And then we can actually just do that in the calculator, which is awesome. In this calculator, I can do math 9. Okay. And then I'm going to just put in the things that I found. So I know that my bounds are from 0 to 1.136. And then I know that the 1 plus sine of 2x was on the top, minus, I've got e to the x divided by 2. And then this calculator prompts me to put in my variable. My variable I used was x, so I've got my dx. Enter, and there is my answer, 0.429 units squared. There we go.